Hello everyone, how are you? Today we'll start with a new lesson with the wave nature of light. Last time we talked about sound and we have finished it. But today we will talk about light. First, what is the meaning of light? Light it's an external factor that affecting on the eye and cause a sense of vision. So first, let's talk about the nature of the light. Light is electromagnetic wave. Why? As it propagates through vacuum. And it is transverse wave. Why? As the medium particles vibrate perpendicular to the direction of wave propagation. So last time we talked that the sound is mechanical and longitudinal wave. But today we will talk about that the light is electromagnetic wave and transverse wave. Second point we wanted to talk about it, the speed of light. The speed of light, it is the distance covered by light in 1 second. And the speed of light in space equal 300 millions meters per second. So we can get the speed of light distance over time. And we can measure the speed by meter per second. So all the light that come from the sun, we can't see it. We can see only the visible light. So what is the meaning of the visible light? It's one of the components of electromagnetic spectrum of wavelengths ranged between 380 to 700 nanometer. It is the light that we can see it. Next point we will talk about the analyzing of white light. A glass triangle prism analyzes white light into many colors. We have 7 colors, which are red, orange, yellow, green, blue, indigo, and violet. Each color has a certain frequency, and when the white light passes through the prism, the color deviates with different angles and analyzes. And they are called the color of spectrum, or 7 spectrum color. Again, what are they? Red, orange, yellow, green, blue, indigo, and violet. So we have a physicist, it's called Max Planck, proves that the light consists of packets of energy, are called photons, And this energy of photons is directly proportional to the frequency. So when the frequency increases, the energy of photons increase and vice versa. So the energy of photons equal Planck's constant times frequency. We have 2 important lights, which are red and violet. The frequency of red is less, while the violet is bigger. The energy of photons in red smaller, while in violet bigger. And vice versa for wavelengths. The wavelength of red is large while violet is low. So we have directly proportional with energy with what? Frequency. So when the frequency increases, the energy increases and vice versa. So now let's talk about the behavior of light through different media. So we have 3 different media: transparent, opaque, translucent, or semi-transparent. Transparent material like air and pure water, they permit the light to pass through it. Most of light pass through it. While in opaque medium like wood and metal, like skin, like a lot of material, they don't permit light to pass through it. Finally, translucent medium or semi-transparent medium. Translucent medium or semi-transparent medium, like flint glass and tissue paper. They permit a part of light to pass through it and absorb the other. Next, let's make an activity to prove this property. We have important property about light, which is that the light travels in a straight line. The aim of this activity to prove that the light travels in a straight line. What are the tools? 4 cards, piece of clay, light pen, and white A4 paper. The steps: make identical hole in the medium of these 3 cards. Fix the 4 cards using a piece of clay on the white paper plate where the hole lie in the same line. Allow light of the line pen to pass towards the hole of cards. What you observe? A spot of light is formed on a card D. The light spot disappears if card B or C is moved slightly to left or right. So we can conclude what? That the light travels in a straight line in transparent medium. Next, we will talk about the light intensity. First, let's make an activity. This activity, the aim of it, to identify the light intensity or brightness for a given surface. Direct a torch toward a wall in a dark room. Change your distance from the wall. What you observe? The light intensity is changed according to the distance between the source and the wall. So we can conclude what? In position 2, the light incident on the unit area decrease. So we can define light intensity. It is the amount of light incident on a unit area of a surface in 1 second. And the light intensity increases as the distance between the surface and the light source increase. Again, light intensity decreases as the distance between the surface and the light sources increase. So the relation between them is inversely. So we can say that the inverse square law of light states that the light intensity of a surface is inversely proportional to the square of the distance between the light source and the surface. So the headlight of some cars are mercury lamp to give a bright illumination that show other cars in the fog at night. This bright light repair the vision of the driver of the cars coming in the opposite direction. Thank you and see you next time. Bye.